Hello folks, in this lecture video we're going to be talking about balancing chemical reactions or chemical equations, okay? And that comes from the first law of thermodynamics, which means to say that matter cannot be created or destroyed. That means to say that if you cook with one chicken, you should not end up with 5 wings and 20 drumsticks at the end. Unless you're Jesus, of course, you know. But anyway, so the first thing is, to a lesser extent, is the number of electrons lost and gained must be equal at the start and end of reactions. If you look at this chemical equation, you can see that hydrogen has a plus charge and chlorine has a negative charge, but the overall charge of this side, the reactant side, still equals 0, okay? And if you can see HCl, what's the charge on that side? That is also 0. So again, that's a lesser extent. But that's also a very, very important way that you actually start reactions, okay? The number of atoms participating in a reaction must be equal at the start and end of reactions. You have one hydrogen atom, you have one hydrogen atom on the product side, you have one chlorine atom on this side, you have one chlorine atom, okay? If we do the masses, and this third bullet here, folks, is going to be more when we're going to be talking about stoichiometry, which is going to be probably in the middle of the semester, okay? And this is one of the reasons why we balance chemical reactions. What we're going to be doing in this lecture video is we're going to be going through a bunch of examples. Well, not a bunch, but 4. And we're going to proceed with the next step. So here we go, folks. We have a combination reaction. We have a single replacement reaction. We have a double replacement reaction. And we have a combustion reaction, okay? Redox reaction, redox reaction, not the redox reaction, redox reaction. And again, this also comes from your reaction videos. So you make sure that you have viewed those videos before you even proceed. So we're going to balance. In this case, all of this are neutral for our purposes. Okay, so now we're just going to be looking at atoms in this case. We have 2 hydrogen atoms, and the best thing for you to do, folks, is you list. Okay, so you have 2 hydrogen atoms here, and you have 2 hydrogen atoms there. So far, so good. It's balanced initially. Now here we have 2 oxygen atoms. Guess how many oxygen atoms we have? We have 1. So right now, again, if we have 2 here, we better have 2 there. And one of the ways that you do this is through multiplication. And this is where coefficients is going to come in. So you have to think, what number do I need to multiply 1 by to get 2? And that answer should be 2, correct? So I'm going to multiply this whole cluster with 2. So now 2 times 1 is 2, right? So now I have 2 oxygen. But here's the problem. What happened to our hydrogen atoms? 2 times 2 now we are now up to 4 hydrogen atoms. And how many do we have here? We have 2. So what do we multiply 2 by to get 4? We put 2. And again, this is where the coefficients come in. So the balanced chemical equation for the creation of water is you have 2 H2s plus 1 O2 gives me 2 H2Os. So that is balance at that point. All right, this is where coefficients come in. So now we're gonna do a little bit more of a confusing thing. So now we're gonna be looking. So maybe I should keep that in there. So there's a 2 in front of this one. So this is a single replacement reaction. Now, first of all, folks, in order for you to balance chemical equations, you need to make sure that a reaction has to occur first. Now remember, this is a single replacement reaction, which means we have to use our activity series. It just so happens that sodium is higher than lead in the activity series, so therefore this reaction is actually going to proceed. All right? Now here's the deal. When you see nitrate, nitrate is a polyatomic ion. And if you see polyatomic ions occurring at both sides, like there's nitrate here and there's nitrate there, you will not split nitrate into N and oxygens, okay? You will balance them as a unit. So that means to say that we're going to count them as 1 unit. So how do I talk about this? If we look at nitrate, nitrate is NO3. If you look at the subscript, there's 2 of them. So how many nitrates do we have on this side? We have 2 nitrates. That's how you should balance as long as the polyatomic ion occurs on both sides. And how many nitrates do we see here? Since there's no parenthesis, we know that there's only 1. All right. So we have 2, we have 1. We always multiply the lesser side. So we're going to multiply this whole mess with 2. Okay. So now we have 2 nitrates. Okay. But now what happens to our sodium, folks? Now we have 2 sodiums. And as you can see, there's only 1 sodium here. So we're going to put a 2 in front. So the balanced chemical reaction, folks, if I'm going to scratch out all of those other extraneous things, okay, is, it actually looks like this, right? Lead nitrate plus 2 sodiums gives me 2 sodium nitrates plus 1 lead. 1 lead, 1 lead, 2 sodiums, 2 sodiums, 2 nitrates. Since there's a 2 in front of this whole mass, that means there's 2 nitrates as well. Okay? I should have kept that, but we're just gonna try to be neat here. So what happens again, same rules apply here. It's a double displacement reaction, and we know it's gonna occur because we need to look at the solubility tables of ionic compounds. And again, if no solids happen at the end, no reaction is gonna occur. And FYI folks, if no reaction is gonna occur, you don't have to balance the chemical reaction or the chemical equation. Okay, so in this case, again, we're gonna go the same way that we've done before. We are going to consider nitrates and hydroxide, since hydroxide and nitrate are polyatomic ions, as one unit. And the reason why we can consider them as one unit is because there's a nitrate on the reactant side. There's also a nitrate on the product side. There's a hydroxide on the reactant side. There's also hydroxide on the product side. The only time that this is not gonna work is if the polyatomic ion only exists on one side of the chemical equation. Okay, so we're gonna do some balancing here. FYI, you should always balance. Again, we're gonna probably talk about that later, but we're gonna proceed with this thing further. So how many nitrates do you see here? Nitrate, there's a parenthesis, there's 3, so guess what? There are 3 nitrates. There's only 1 nitrate here. What number we need to put in front of sodium nitrate to make this into 3? We need to put 3, right? So you guys can see now 3 times 1 sodium is 3 sodiums. 3 times 1 nitrates is 3 nitrates. So we have 3 sodiums. We have 1 sodium here, right? So we have 1. So we need to multiply this whole mess by 3. I hope this is making sense at this point. So now what happens, folks, is we have 3 sodiums. And guess how many hydroxides do we have? We have 3. Right? Now look, folks, look what happens to hydroxide. How many hydroxides do you see on the product side? Well, there's a subscript 3 and there's actually a parenthesis. So therefore, that means you have 3 hydroxides. 1 sodium, 3 nitrates, 3 sodiums, 3 hydroxides, 3 sodiums, 3 nitrates, 1 iron, 3 hydroxides. So as you can see, the number of atoms or the number of ions on both sides are equal. So that is how you balance that equation. All right. So there's a complication. There are some equations that takes longer to balance than others, and this is probably going to be one of them. This is a combustion reaction. It's a redox reaction, and we're gonna, for this case, you always balance hydrogen and oxygen last. If you see hydrogen and oxygen as individual atoms, you will balance them last. So I'm going to balance oxygen last. Okay, so I have 3 carbons here. Okay, I have 1 carbon here. So what do I need to multiply this by to get 3? Obviously it's gonna be 3. So we have 3 times 1 is 3. So now we have 3 carbons. I should probably erase the previous one, that way it's not gonna get in the way. All right, so far so good. Okay, go back to this. Okay, now we're gonna balance. Remember, we're gonna balance oxygen last, folks. We have 8 hydrogens here, 8 hydrogens, and we have 2 hydrogens here, right? So we have 2 hydrogens here. What number do we need to multiply 2 by to get 8? We are definitely gonna put 4 there. So now we have 8, right? So we have 8 hydrogens, 3 carbons, 3 carbons. But now the oxygen is going to be a problem. If you look at the product side, oxygen is in 2 different places. 3 times 2 is there are 6 oxygens, but it's in 2 different locations. 4 times 1 is 4 oxygens. So what's the total number of oxygens? 10, right? How many oxygens do we see here? We only see 2. What number do we need to multiply 2 by to get 10? We're going to put a 5 in front. So in a balanced chemical reaction, we have, this has no coefficients in front. That's a 5 coefficient in front of oxygen. So 5O2, 3CO2 plus 4 waters. And if you do all the counting of atoms, you should have to have equal number of atoms. 3 carbons, 3 carbons, 8 hydrogens, 4 times 2 is 8, 10 oxygens, 6 plus 4 is 10. So in that case, this whole reaction is balanced. Do a lot of examples. It's going to be in your homework problems as well, and that's the only way that you're going to get better with this.